Today, we sit at our desks and conjure digital brushstrokes or synthesize entirely new voices with a single keystroke. It feels like magic, and we've completely normalized it. These commercial tools operate under a specific technical classification: artificial narrow intelligence. Narrow AI operates with limited memory and remains dormant until a human provides a prompt. It lacks the ability to initiate any action on its own. This call-and-response dynamic defines the software as a digital instrument. It sits in a toolbox, waiting for a person to pull it out to perform a specific task. We have mastered the use of tools. Now, that relationship is changing as AI becomes a proactive colleague we work with. This transition started as pure theory in 1950, when British mathematician Alan Turing conceptualized a machine capable of thinking and learning. At the time, computing relied on massive machines that filled entire rooms, functioning as large-scale calculators operated by teams of human workers. Researchers spent decades trying to actualize Turing's theory, but their ambitions outpaced the physical hardware of the 1970s and 80s. This gap led to the AI winters, where funding stalled and progress slowed. What finally broke the stagnation was the artificial neural network. By structuring nodes to process data in layers, researchers mimicked the human brain. Scaled up and fed massive datasets, this became deep learning, capable of identifying complex patterns without explicit programming. Applying that deep learning architecture to billions of pages of text birthed large language models. These systems map the complex relationships between words to understand the context of human language. Decades of physical hardware upgrades and mathematical struggle built the foundation for an engine capable of understanding complex instructions. Understanding an instruction is the first step, but independent execution is the next. This marks the transition from standard chatbots to agentic AI. An AI agent breaks a complex goal into smaller steps. That's planning. It applies reasoning to navigate unexpected obstacles, interacting directly with digital environments to carry out its plan. Finally, it evaluates the outcome, learning from the experience to improve its next attempt. This four-step autonomous cycle creates an independent digital worker. By 2026, autonomous agents will be integrated directly into professional workflows as active colleagues. In software development, agents are analyzing the history and context of code repositories. They trace how software components interact, locate hidden errors, and automatically implement fixes. In the sciences, the AI acts as an active lab assistant. It generates its own original hypotheses, designs testing methods, and runs experimental simulations. We are seeing results in healthcare too. Recent Microsoft diagnostic orchestrators have solved highly complex medical cases with an 85.5% accuracy rate, outperforming the historical averages for these challenging diagnoses. When researchers pair this level of AI pattern recognition with the processing power of quantum supercomputers, they can model complex molecules and materials at speeds once thought impossible. With a projected global shortage of 11 million health workers by 2030, these autonomous systems are actively helping to close critical gaps in knowledge and care. Granting autonomy introduces new risks. Without oversight, independent agents can be exploited by malicious actors, turning into unchecked double agents within a secure network. Organizations are building security directly into the architecture to prevent this. Every agent is assigned a strict digital identity, with explicit boundaries on what data it can access and which systems it can modify. Assigning complex tasks to autonomous software creates a clear tension between automated efficiency and human displacement. In practice, a 3-person team can now launch a global campaign in days, relying on agents to crunch data and personalize content, while the humans direct the strategy. Success in the 2026 workforce ultimately requires the ability to synchronize human intent with a new kind of autonomous digital